Good evening, everyone, and welcome to a very special edition of In the Box Live. I am Annibal, but you can call me Annibal, and I am here with the legendary Daniel Krawisz, aka Cosmos Stagittarius, aka Satoshi Nakamoto 3.0. He is off screen right now. You like that one, did you? How you doing, man? Welcome.
Thanks, and thanks for the great introduction. And I'm here to talk about how to get started with programming.
Yeah, this is something that's generated a lot of hype in the last little bit. We're really excited about this. Um, I don't know if a lot of people know, but there's been a really kind of not very many people doing this, basically. Um, so, you know what? I'm just going to let you take the reins, man. You're ready to go. So you jump right into it, man. This is all you.
Okay, Animal. Great. What did you mean? Not many people doing this. What do you mean this? Hello?
Well, you were saying that basically that there should be, there's kind of a lack of programmers that are building on BSV right now. There's basically plenty of opportunity and a limited amount of people actually out there doing it in the trenches. Would that be
Right.
an
Yes,
accurate
that's
statement?
kind of a problem we have right now. There's kind of a labor shortage in BSV,
Okay.
and we had some good programmers back in BTC, but they got all thrown out of the community, or they got tricked and they became core supporters. So all of their work was kind of wasted.
Okay. Gotcha.
And like Bitcoin is really, it's kind of weird because nobody can make anybody do anything for the most part. People have to want to contribute and just sort of decide of their own free will. And the people who understand that BSV is uh, a winning community um, are not are not necessarily people with technical knowledge. They're more like, well, I mean, it's just uh, it seems like it's just common sense to me that that BSV is winning because we're trying to make products and services for each other and for the outside world, whereas in BTC and in the other coins they can't really do that because what they've got can't can't be used as money.
Sure. Right.
Okay, um uh but in Bitcoin, because there aren't very many people, you have to take some initiative and you have to figure out what skills are needed and acquire them yourself. So this is about
Sure.
how to get started with programming. So as I said here, the most difficult thing about learning to program is believing that you can't do it. And this is something that I've seen uh, again and again from people. Uh, um, Before, well, people have trouble imagining themselves having mastered a skill. So before they know anything about it, there is a tendency uh, to uh, um, um, there's a lack of imagination about yourself, I think. And I think people have an idea that programming is something that's very that it is requires a very high intelligence, uh, but programming isn't really. It's not like being a mathematician or a physicist. I think most people can learn to program, and programming is a skill that's more like writing, which is, something that most people can do. And, some people can produce writing that lots and lots of people want to read, but just about everybody can do some writing that, that expresses themselves adequately. And right now, our society is, it doesn't teach programming to children at a young age, but programming is going to be kind of like learning to read. And that you did that, um,
Right.
so you should take it up. There's a lot of opportunity, and there's some good tools for programming on Bitcoin now. And people who already know how to program don't understand why Bitcoin is good, so they're not doing it.
Right, right,
um,
right. And I can tell you, I've never programmed a thing in my life. I mean, I've failed at programming remotes to try to pick up my television before. So I'm really excited to hear, just sort of from a newbie's perspective, how to get involved in this, because I think you're absolutely right that it is really important to kind of stoke the flame of the BSV programming community. Um, so again, I'm really excited to get into this.
okay, well, just think about learning to read, and it's probably going to be kind of like that. And it's not, it takes a lot of work to get good at it, but it's not something that is outside the means of most people, I think. So um and uh programming your VCR isn't that's not really the same thing.
No, I'm
So
sure it isn't. I'm sure it isn't. That's the whole point, though, isn't it?
a computer is a machine that represents and transforms information according to rules. So you've got your memory in the computer, and you've got your CPU, and the CPU uh, grabs data from the memory and then transforms it into something else and puts it back in the memory. All computers are they kind of work along that principle. And programming is about writing instructions to tell the machine how you want it to perform information. So a programming language is a representation of instructions for a computer that is adapted to be human readable. So a programming language is a human to human communication tool, as well as a human to machine communication tool. Um, and so the programming language bridges the gap between the human mind and the machine.
And I'm going to stop you for just 1 second, and I'm going to call out some people in the chat really quick. First off, thank you all for joining us if you've tuned in so far. And as we go through this, I spoke to Daniel prior to this, and we're really looking to get a lot of questions for Daniel to answer. So if you have anything, if you're thinking of any kind of questions about this, please drop them in the chat. And I don't think Daniel's watching the chat, but I definitely am. And so I will be relaying all of your questions to him. Um, but please ask your questions. Sorry, carry on, Daniel.
Yeah, I don't have the chat in front of me, and yeah, and feel free to ask me stuff if you actually get started later, because I'll help you get started programming for real. In this presentation, we're not going to do any programming. This is more of a pep talk
Cool.
to convince you that you actually can do it.
I love it.
Um, so stuff in programming languages. There's basically two kinds of things. There's oh wait.
Real quick, I've already got a question for you. What's the best coding language for BSV?
Okay, well, the
If you're
best,
going to get to it, we can wait.
yeah, well, I am, but the best one to get started with now is JavaScript. And
Cool.
there's the reason for that is there's good tools available. So there's like the Money Button BSV library, and there's also tools in JavaScript for every other possible thing that you could want. And I'm personally not a big fan of JavaScript, but it's ubiquitous, and
Right.
and everybody uses it, and there's lots of prior work.
I
So
think
that's
it'll give a lot of people comfort that you can code BSV in JavaScript. I think
yeah.
only
Well,
because it's familiar.
but one thing that we really need is making libraries in other languages. Because right now,
Sure.
I think JavaScript and C++ are really the only languages that actually have tools for BSV that are any good. And I'm not aware of anything being done in other programming languages. But what we ultimately would want is for people to be able to program to use Bitcoin in any programming language. And right now we can't do that. So there's older stuff in many other languages that was for BTC. So someone might be able to take some of that and modify it. But
Okay.
making a library is kind of more of an advanced kind of thing. So my recommendation for somebody who's never programmed is just start with JavaScript.
That's great information. Thanks, Daniel.
So in programming, there's basically data. Those are sequences of ones and zeros. That's the only thing in a computer. And then there's functions, and the functions act on the data. But a function is also data, um, as as well. I'll talk a little bit more about that later. But the function is a a way of transforming data. Oh, and there's a potential confusion because a function in math is different from a function in computer science. And the difference is that functions in computer science don't always return a value, because you can program something that goes into an infinite loop or that crashes your computer. And that's not what a math function is supposed to do. A math function is always supposed to return a value. So if you're a mathematician, functions in programming are actually what you would call a partial function. But and so this is poorly named. Um, the computer scientists stole this word from mathematicians and they used it incorrectly, but they do that a lot.
Okay. Yeah, that makes sense.
Um, so all transformations of information can be represented as operations on numbers. So you can represent any number as a sequence of ones and zeros, just like how we represent numbers using 10 digits, 0 to 9. You can just use 2. So you can think of the data in the computer as being numbers, and the transformations of the data as being arithmetic operations. And programmers typically do not do very difficult math. It's usually more like arithmetic, like simple math. And if you need to do more complicated math, most likely somebody's already done it for you, and you can just take their library.
You sort of copy and paste.
Right. Well, yeah. Um, well, but not literally, because you can just include the library in your program. You don't have to
Right.
actually copy it. Um,
Awesome.
and a good programming language provides tools for imbuing meaning into meaningless operations. So programmers are the Nietzschean Superman, because that's kind of what programming is. Um, there's an inherently uh, meaningless um, system, which is whatever, because the computer can do all kinds of things, and most of them are useless. You're trying to create meaning, and the programming language gives you tools for making meaningless operations meaningful. And you need to find the natural morality, just like the Nietzschean Superman. The most important skills in programming are communication, and so it's much better if you write something that other people want to use. So you have to write code that is easy on the eyes. So people need to be able to read it easily. And I think that
Just real
this
quick,
is
Daniel. Sorry to interrupt you. Astronomy Dork is asking, what is Bitcoin script? There's a question for you.
Bitcoin script is a simple programming language that's similar to Forth. Um, and uh, I don't know. Does he have any follow up on that? It's I
The
don't I
follow
don't
up is a smiley face,
I
so
don't need
not so
to.
much.
I hope I don't need to explain the whole thing, but I do actually have
Okay.
another presentation on introduction to
Yeah.
Bitcoin where I
Yeah.
can
We'll
go
dig
more
deeper
into
into
that.
that.
But
Yeah, well, for sure. And one more thing, really quick. Rhythmic Eye says, is there a preference between code for human to machine and code for machine to machine, etc.?
well, there isn't. Well, there's the the computer natively runs a programming language that's called assembly, or different architectures work in different ways. Uh, that's not well. Uh, I mean, that's not quite right. Assembly is still a human readable version of that. But um, uh, when you copy an executable file from one computer to another, that's sort of machine to machine, because you're just copying the information that the computer natively follows. But
Okay.
a programming language means that we're talking about something for humans. We're talking about an interface between machines and humans, and
Gotcha.
uh, the native operation of the machine is not something that humans can understand very easily.
Sure.
So the three most important skills: communication, managing complexity, and preventing bugs. So when when you program, there is a danger that you will not understand what you've created. So that's kind of what managing complexity means. Like if you're not thinking ahead, you'll end up with something that's too complicated for you to follow. So what you need to do is solve uh, is subdivide problems and solve simpler and simpler problems. And then you can build bigger solutions out of that. Um,
Now, is this something that certain APIs will help with?
well, and an API means that you're calling another computer. Um,
Okay.
I mean, uh, well, that's not really true. An API means that because you can have that, you can have an API in a what does API stand for? I don't remember.
Ooh, I'll look up
It
really
stands
quick.
for application programming interface.
Yeah, you beat me to it. You
But
nailed it.
yeah, that's sort of what you want to design as you create a program. I have a little more on that further on.
Right.
And so a bug is um, it's anything the program does that you don't want it to do. And so there's an infinite number of ways that a program can misbehave. So bugs are a big problem. And remember what I said about imbuing meaning into things. So if the computer just kind of behaves randomly, it's not likely to be doing something meaningful. So the subset of meaningful things that a computer does in relation to the number of possible things is very tiny. So you're constantly avoiding bugs as you program, and getting good at it is um, is uh, um, avoiding bugs at earlier and earlier stages. So, while I talk about that a little more over here,
Basically, what you're saying is sort of going into the project, understanding like how to minimize bugs from the get go instead of dealing with them after, in a way.
right? Yes. So you want to think defensively, and
Sure.
you need
Yeah.
to
Okay.
um, develop good habits that will um, uh, that ensures that the your the meaning that you think that you are imbuing into the program is in fact what you're doing, and that will um, the program will maintain the constraints that you expect it to have right from the start up until the point that you finish.
Yeah,
So
that makes a
that's
lot of sense.
um,
You're sort of foolproofing the whole time, in a way.
right. Yes, that's programming, because everybody is a fool and nobody can just write perfect uh, programs. Everybody
Gotcha.
everybody is making mistakes constantly, so it's kind of an endless war
So it's
against
just good
bugs.
practice, just good practice to just be constantly trying to debug as you go.
Well, debugging is what you do.
Well,
Uh,
preventing bugs rather.
yeah, debugging is what you do after you know there's a bug. So if you're
Sure.
doing that, it's already too late.
Gotcha. Yep.
So here's my advice on preventing bugs. So the first thing is you define the correct behavior of your program as early as possible. And well, let's start up here. Most important resource is the programmer's time. So there is a tendency for beginner programmers to to act as if the computer's time is more valuable than their time. So they try to make they try to make the computer run fast at the expense of writing code that is readable, and at the expense of their own time. Because if you don't have readable code, then you end up spending a lot more time getting it to work right later on. So typically, um, yes. So your time is what you need to optimize when you program, and computer's time is secondary. So there's a famous quote from Donald Knuth. It says, "Premature optimization is the root of all evil.
So you're
So
saying get the code laid down first, optimize later is the idea there.
yeah, um, yes. So you want to create in stages, and you
Okay.
want to iterate the process. So
Right.
typically, there's going to be a main loop of a program that runs a lot more than everything else. And if you just make that part fast, then the whole program is fast enough, and the rest of it you don't need to worry about. So, an example of how this works, or uh, how this works in the real world, is Python with C. So C is a very fast and relatively low level language, and then Python runs on top of it. And you can call C functions from within Python. So you can optimize the parts that you need in C and make them work really fast, and then do the rest in Python, and everything will be a lot easier. Then I put C++ with itself. So C++ is my favorite, and it has um, tools at every level of abstraction. So you can write at a very high level in C++ for the most part, and then get right down um, and in it, right down into the details for the parts that need to go fast. So a way of making efficiently using your time is focusing on defining problems and trying to get the computer to solve problems. So defining problems is the human's job, and solving problems is the computer's job. And if you can um, if you can specialize yourself in solving problems, and or in defining problems, and then specialize the computer into solving problems, that's the best way to optimize your time, I think. So avoiding bugs has to do with defining the program correctly first, uh, and then write the program in a way that other people can easily understand it, um, and then test-driven development. So what this means is you write, well, you always want to write tests when you program, but test-driven means that the tests go first. And if you read into this idea, there's some real uh, there's some people who believe in test-driven development to a like the real sticklers about it. I don't think that you need to adhere to all of the rules of test-driven development perfectly, but I think the basic idea is sound, because you once you have tests, then then it's easy to sort of mess around with your program and change stuff. So it's like it's always young when you have tests.
So would you consider it important to get to that testing phase quickly? Do you think
Yeah.
it makes the rest of the programming process easier?
Yes. So let's see. Where did I do this? Development cycle. This is what I think the development cycle should be. First, you define your problem, and then you design your interface that solves that the interface for the machine that's going to solve the problem. So uh, then you create tests, and then you construct the implementation. And if you do the first three steps well, the last step can be complete crap, because you can redo it whenever you have time.
Okay, cool.
So this is the program life cycle. And most programs basically follow this pattern. There'll be a phase where you translate user input into abstract representation of a problem. So user input can be mouse clicks, or it can be text, um, and you will need to translate that into a representation of what the user wants. Then you solve the problem, and then you translate back from the solution into a human readable representation. So
Okay.
if you organize your programs like that, that's that's usually how they need to work.
So real quick, Chief Naples here in chat says, does Daniel have any programming books to recommend, or does he have his own courses or anything he has done?
Yeah, programming books to recommend. Let's see. Um, I think if you just Google search that, you'll be able to find a PDF of this book. And a scheme is it's the dialect of Lisp, which is a very important programming language.
Okay.
And this book is very good because it starts from nothing, and it goes through very simple. Well, I think that there are 10 chapters, and the first 9 chapters are just extremely uh, basic things. And the
Hmm.
10th one puts them all together, and it shows you how to make the Y Combinator. So this is a very good book. Um, I don't have any other recommendations that I can think of.
Peter V has pointed him towards some of your write-ups on Matterpool.io as well. I'm not sure how much of that is really digging deep into programming, but I can attest there definitely is some really good material there. Go check out his
Oh, well,
writings.
thanks. Yeah, none of that has anything to do with programming.
Sure, no, it doesn't, but nonetheless, good reads.
So well-designed programs are layers of interfaces. So you want to so your program is going to be solving like one big problem, and the user of this program wants will want the program to just handle everything. So the program is going to have to take care of um, every possible input that the user can give it, and most of those inputs will be invalid. So then it has to deal with errors, um, and and it has to make the experience easy for the user. And internally, uh, there should be many representations of that same pattern, except that the user isn't a person running the program. The user is another programmer who's using the tools that you have given him. So I have this idea here called the junior and senior programmer, and those are really both you. But you should, when you are designing an interface, you design it for the junior program. So you make it easy for him to use, and then you solve every possible problem for him within the interface. And you build your program up as layers of interfaces that solve bigger and bigger problems. And if you can do that, then you'll manage complexity, and you won't end up with something that's too complicated for you to understand. So typically, when people start programming, they don't have a sense of how complex a relatively simple problem can end up being. Now, computers are stupid. So um, so you have to tell the computer to do everything, and you have to tell it how to do every single little detail, and it has to get everything right. So uh, seemingly simple problems can end up being uh, quite complex when you actually write them out. And this is how you manage that complexity. Um, and uh,
So in
a
a way,
big
you're saying kind of dumb it down for yourself as you go to be able to keep up with the whole thing at the end is sort of the vibe there.
right, yeah, oh yeah, that's a good way of thinking about it. Yeah, so uh, you want to design your interfaces to make things easier for the user, and the user is just you. And once
Right,
this
right.
the problem once the problem is solved, then you get to be the junior programmer who uses the interface. You're the senior programmer when you're creating the interface and the inside of the interface, and you're the junior programmer when you're using the interface. And uh, you you want
It's
to make it easy for the junior programmer
it's
because
excellent.
he's
I
not
love.
very smart.
Yeah, I really love that analogy. That makes a lot of sense. That's great.
So and okay, I talked about this, and you can take a bottom up or a top down approach. And the top down means that you start with the big problem that you want to solve and subdivide it into smaller problems as you go, and then repeat as needed. Whereas bottom up means you start with the smallest units. You start with like the prior work, the stuff that other people have done, and you put them together into bigger machines. And these two approaches kind of depend on how well how which problems you understand well. So if you already know what problem you need to solve, then um, a a bottom up approach is probably better. But if you need to figure out what you're doing as you go along, then a top down approach is good, because you can keep the big picture. Well, you start with the big picture, and you figure out smaller problems as you go.
Can you maybe give me an example of a big problem, something you may have encountered in the past? Like, what would you consider like a big problem versus a small one? Just a random example.
Oh, okay, sure. Well, let's well, I'll just show you the library that I'm working on. So let's
Cool.
see. Um, okay, just a sec.
No problem.
Uh, Here we go. Okay, so here is um, some stuff I've been doing. Okay, so I have a library called, oh no, it's fine. Um, I just realized that I should close that. Um, so
Nobody look.
I have a library that's in C++, and it's called GigaMonkey, because that's my name for the Bitcoin egregore, which will eventually include all humans.
Awesome.
And so everything is I'll show you how I've built things up. So here's keys. And for some reason my IDE isn't coloring everything in really nice like it's supposed to, but I don't know why. So I've got a point for an elliptic curve, and I've got a type for signatures, and a type for the digest, which is what's returned by a hash function. And then I've got the secret key, and I've got the public key. And there's some implementations of functions down there.
Wow.
And let's see. Then here's where I have implemented some of the functions for these keys. And sorry, I'm finding stuff. Here we go. So this is a standard library that is written in C that I call, and it's the SECP 256K1 library. And this library is solving a smaller problem. It does everything and this is an interface that I made that solves a bigger problem. So this library, which is the only good thing that the core developers did, does everything that you need with the Bitcoin keys. And it is
Wow.
written in C, which means that it does not manage memory.
Okay.
So here's their pub key, and it's just an array that's 64 bytes long. And let's see, here's their signature. I don't know what any of that stuff means. Well, here's some there's a lot of stuff with the macros. I don't know what's going on with that, but here are some functions. This says, well, I don't really know what this part means, what the context does, or what it is, but I know how to use it. There's a verify context and a sign context, and I don't know what's going on behind the scenes with it. But what I've done is abstract all of that stuff away. So what my interface does is it passes on parameters to the SECP 256K1 library, and it also manages the memory, and it manages these context variables, which store they store cache data, I guess. But when you use what I've done, you don't have to think about anything like that. You just have a type that represents keys, and here are ways of creating the keys, and here are operations on the keys, and it just always works. It handles the whole life cycle of the type of the data, and it's easier for somebody else to use in something else. So I hope that was a good example. I know I didn't really
No,
explain
that
very
was
much,
great. Sorry
but
sorry to send you down that massive tangent of a path. I feel responsible, but I'm really glad you shared that. Thank you.
oh, okay, good. No, uh, No, anything that helps is good. Now, I realize most people haven't done C++ and probably don't know what any of that means, but that's just kind of uh, uh, yeah, that's an example of how I think you should program. Um,
Oh, that was great.
you take problems that somebody else already solved and put them together into to bigger problems that are a, able to be part of something bigger. Okay, so here I've got important programming languages. I think Python is actually just lowercase, but whatever. I've got these are the most useful programming languages, I think. And anytime you start talking about which programming languages are good and bad, you start a religious war. So just whatever. Some people are going to say that some of these languages are terrible and my choices don't make any sense. But I think these are the most useful languages. Um, uh, because they're popular and there's a lot of prior work and you really can't avoid them. So I don't really think that well, I'm not really a big fan of actually using Python or JavaScript myself because they don't really have the features that I think are the best, but um, they but on the other hand, they're kind of going to open up the most for a new programmer. Now, Python is probably the easiest programming language to get started with, and it's all open source, and there's tons of stuff for it. It's probably already on your computer, so you can get started right now. But unfortunately, I don't think that there's a lot of Bitcoin stuff for it. Now, there was a library that Vitalik Buterin made a while back, but that was for BTC. So
No,
somebody would have to adapt that. Yeah.
correct me if I'm wrong. The Twetch SDK is built on Python, right?
No idea.
No
I don't.
idea. Okay.
I don't know what.
That's a question
Um,
from Dookie Love, by the way. I can't take credit for that.
I don't. I don't know what they're doing, but uh, um, uh, what does SDK mean?
It's software developer kit, I believe.
Oh, okay.
It's just like their
I don't know
their
why,
toolkit.
and I don't know. I'll look into it, but I don't know what they're doing with that at all. But if 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 it is, then that would be a good sign because that means that there is Bitcoin stuff for Python. But I don't know what they would be using. There's also Electrum SV, and I think that's in Python, but um,
Okay.
you would have to dig into that and sort of cut out stuff if you wanted a Bitcoin library from it.
Right. Okay.
Now, C++ is my favorite, and a lot of people hate that one, but it's it's considered to be a language with a lot of pitfalls. But I think that once you get good at programming, you realize that you're just dealing with those kind of pitfalls all the time, no matter what you do. And they're not really that bad. And C++ has tools that most other languages just don't have. So I think that C++ just gives you a lot more. Um,
So you would say that maybe Python and JavaScript are easier to kind of dip your toes into, and then C++ has more flexibility in a way.
yeah, I would say C++ is more like something that an advanced programmer would like, but
Okay.
that's no reason not to get started with it. But it's
Sure.
definitely going to take you longer. C++ has more do-it-yourself kind of stuff.
Kind of a
So
steeper learning curve a little bit.
yeah, you're gonna have to learn more tools before you can even do anything with it. And then
Okay.
C is an older, relatively lower level programming language, but it was considered to be a high level language when it came out. Um, but
Technology moves fast, huh?
Right. Yeah. But it's used in everything, especially in systems that don't have that aren't very powerful and that really need to limit their resource use. So C gets you closer to closer to what the CPU is actually doing, whereas C++ uh, is basically the same kind of thing, only with a lot more built on top of it. Originally, C++ was supposed to be a superset of C, but they've since diverged a bit, so they're not quite compatible. But you can still call functions in C from C++. And Python and
Cool.
JavaScript are both interpreted languages, which means that they're slower, but they uh, there's a little bit. Well, I mean, I just don't. I think that, I mean, they're easier to get started on, but I think that any kind of programming uh, leads to uh, leads to pitfalls that you have uh, to worry about. Like, I think that once you start getting the hang of it, you have to program defensively in any programming language. I
Sure.
think that there's been a mistake that people have made periodically in history, which is the idea that you can dumb down programming, and that's how languages like Java came around, and also COBOL. And what you end up with is a lot of complexity without very good tools for dealing with it. So I see Java as a brain fungus that has no reason to exist. And but
Um,
it would
I
be
just didn't
good
want
to.
this to, sorry, just real quick. I didn't want it to go unsaid. You're getting a lot of love in the chat. A lot of people are commending you. Nice job, Daniel. Doing great explaining all this. Just wanted to show you some love, man. I didn't want it to go unnoticed.
Oh, okay, great.
They're all appreciating it very much, as am I. So carry on.
Okay, well, thanks. Yeah, and so here are some languages that are not very popular and are not so good for actually making real projects with. Um, not not because there's anything bad about them. Well, they have they're limited because they're less popular and for various reasons. Like if everybody was using Haskell and there was lots of prior work in Haskell, then I would say we should all just use Haskell for everything. Haskell is really uh, my I mean, in an ideal world, we would all just be using Haskell, I think. But you can gain a lot just by learning about these languages and kind of doing doing exercises with them. So Lisp is kind of a classic, and originally they were going to put Lisp in Firefox instead of inventing JavaScript, but for some reason they decided to invent JavaScript instead. So you should learn Lisp. Oh, and that's what you learn about in the little schemer too. Remember, I said scheme is a variant of Lisp. It's basically Lisp.
Cool.
So you should learn Lisp in order to figure out how JavaScript was supposed to be. They they decided to well, JavaScript is basically a scam because they decided to make it look superficially like things that were familiar to people, like Java, um, when really under the hood, JavaScript is more like Lisp, but it just looks quite a bit different. And I don't see that as a good thing at all. I think that the syntax, the traditional syntax that gave rise to Java and C++ is kind of cumbersome. Well, C++ came first, then Java. But I think that this style of syntax, which has sort of become uh, like the default, it's like many languages are C like. Um, well, I think that it has it's not really the best thing that we could have, and it's kind of not so good to try to copy it. And they could have done Lisp. We would all be better off if we just had Lisp in the browser. Oh, I should mention what TypeScript is. So originally, well, JavaScript is a well, I don't want to go into type theory. Maybe we can do that some other time. But TypeScript is an thing that runs on top. Well, it's a programming extension that is on top of JavaScript, and you compile it to JavaScript, and it adds types like in C++ to JavaScript, and that is something that makes JavaScript a little bit, excuse me, easier to work with.
Okay,
Okay,
that makes sense.
so Mathematica, that's what I'm using to give this presentation now. So that's kind of
Oh, okay.
a language that I learned to program with, and it's a really great one to get started on because the platform just you just turn it on and everything is already all there for you, and you just try anything and it all works. Mathematica is based on Lisp with a different syntax, but it's the same kind of idea, just with tons and tons of stuff built into it. A problem with it is that it is not an open source system, so you can't just get it whenever you want. But Mathematica does some things that other programming languages don't do, like calculus. And I really wish that um, they did Mathematica's symbolic style of programming. I wish that was more widespread in programming. But most of the open source developers are thinking of programming as being for like the web, like serving websites and things like that, when really programming is a thinking tool, and Mathematica uh, really builds up that idea. But there's some things I don't like about Mathematica either. I think Haskell has the best design of any programming language. I don't think I don't think it's really worthwhile to go into it. Just go and learn it, and you'll learn a lot. So Prolog is an interesting one. That's a logical programming language. So essentially, you tell the computer what what you want the output to look like, and the computer just figures out how to find it. So Prolog takes something I said earlier to the logical extreme, where I said defining the problem is human work and solving it is computer work. So you program in Prolog by defining the problem. And fourth is something you need to learn because the Bitcoin script is fourth like. So once you know about fourth, then you know about the Bitcoin script. And then I have languages that have no reason to exist, but that we should support. So if you know any of these, it would be a really good idea to make a Bitcoin library for some of these languages. But I think most programming languages are scams that were invented um, by people who wanted to be important, and they really create more problems than they solve. So I think many of these languages are attempts to make programming easier for people who are familiar with C++. Um, but I don't think that they're going to be able to overtake C++ because C++ already does way more than most programming languages, and there's so much prior work. It's a difficult language to learn, but once you learn it, you can just do a lot more with it. And then when you invent a new language, you end up with a smaller community that has to reinvent a lot of stuff. Many of these languages are like that. Some of them aren't. Like I don't know anything about Swift, but it's used for the iOS, so we need that one. And Java is horrible, I think, but we need that one too because it's so widespread. And I don't like Ruby either. So we talked about this a little bit. Part of what makes a programming language good is prior work. So an imperfect language can beat a perfect one just by having more tools that are already built for it. And to me, that just makes sense. Like if you you just want to be able to build for the least amount of work. So the language itself isn't the only thing that's good about the programming language. Part of it is just what already exists for it. So, but a problem with that is we can end up having really annoying languages in a position where you have to learn them. And that's kind of or somebody has to learn them because there's too much stuff running on them. And that's kind of what happened with Java and COBOL and things like that. So C++ versus Haskell is an example of this because I think Haskell is about as good as C++. Well, it has features that are as good as C++, but it's better designed. But because C++ has more stuff already, it's better to work with for now. But
So
I
even
would
though you work with C++ quite a bit, you say that Haskell really is the number one and everybody should be using it in a perfect world?
yes. So I would yeah, I would like it if everybody learned Haskell
Okay.
just to understand the concepts. Well, so one thing that's really fun about C++ is it's so vast that anything you learn from any other programming language becomes applicable to it. So all of these kind of intellectual languages that I mentioned here, you can all kind of get inspired with them in C++. And Haskell is the only other language that I know of that's kind of that big.
So
But it's,
how much different is C++ from Haskell?
well, they're really different, but there's 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 correspondences that you
Sure.
can define between them. So like the biggest thing is Haskell is a pure functional language, which means that you're not supposed to change data once you've defined it. You just create new objects as you go along, and the functions are first class. Uh, uh, the functions are treated just like data in Haskell, so they're called first class functions, and you can. But C++ is you can do that with C++ because you've got function pointers and you can have objects that are callable like functions, and you can have const methods. And Haskell has the type class system, whereas C++ has the template system. And with C++ 20, they've added concepts, which makes the template system just as useful as the type class system is in Haskell. So you should learn Haskell to understand the concepts, and then once everybody learns it, then they can just start using it for everything. That would be the ideal world, uh, in my opinion.
Utopian society will be using Haskell.
Yes. Oh, so
Okay.
yeah. So oh, I already talked about this. Yeah. So tools, you need tools in order to start programming, and there's more to programming than just the programming language. So you need a compiler or interpreter. This is kind of what makes some languages like Python so easy to get started on, because all of this stuff is kind of like already built into it.
Before we dig too deep into this, I just want to bring up a chat question. What do you think about Elixir?
I've heard of it and I know nothing about it.
Okay, fair enough.
Um, so you need a text editor. Now, if you're a Linux open source purist, you're supposed to use Vim or Emacs, but I use Kdevelop because that's sort of the first one that came up when I searched for Linux C++ IDE. IDE means integrated development environment, but I really just use it as a text editor that colors variables for me. Um, and you need a dependency manager, and that's for finding all of the pieces that you want to put together that were made by other people, like libraries and anything anything that the program depends on in order to run. So there might be like files uh, that need to be part of the program, just anything that needs to exist in order for the program to compile, and that will mostly mean libraries, but it can mean other things. Um, so I use CMake, and you need a version control system, and I use Git for that. And there are other version control systems, but I think Git is definitely the best one, and it is it's another this is another case where there's something that's a little bit more complicated, but it just lets you do a lot more. That's kind of what I think Git is.
That's
And
related to GitHub, yes?
yes, GitHub is a Git repository as a business, and so Git is for distributed development, which is necessary because you want like it's just easier when people can share ideas. So um, uh, but anyway, if you just look on Google and for Git cheat sheet, you can pretty much find something that will tell you almost everything that you ever need to do with Git. So for the web, you also need to know HTML and CSS. Um, HTML is for defining the structure of documents, and CSS is for formatting. And then JavaScript operates on the documents and changes them and makes them dynamic.
Dang
And
it,
this
man.
is
I just got to stop you because I have thought about HTML and CSS and JavaScript a lot over the years, and that little 5 seconds was the best explanation I've ever heard of that. So just wanted to applaud you for that one for a
oh
second.
well, thanks. Yeah, and this is kind of another good thing about starting with JavaScript if you include these two, because then you kind of have a graphical user interface that's kind of all set for you. That's easy to create. I mean, both HTML and CSS. Well, all three of these things are just kind of crazy, but they're what everybody uses. So you also need a backend language, but you can use JavaScript for that too. The backend is what runs on the server that serves the page, and then JavaScript runs on the client's computer when it's making the page dynamic. And then you need a database, and these are just some examples. You can use Bitcoin, or you can use your hard drive. That's a database. And then there's SQL based. So SQL is a database querying language. And then there's also this trend for no SQL databases, which, well, I don't. I think it's better just to use SQL. I don't. I think that's another thing where people aren't really doing a very good job solving problems. So programming paradigms, there are three main ones: imperative, functional, and logical, also known as declarative. So imperative means that you're giving the computer commands. That's what it's like to write it. And functional means that um, you're defining the operations that you want the computer to use. So that's a little more like how a mathematician would write things. So this is like Haskell and Lisp, and this one is like C and C++, and then this one is like Prolog, and also like HTML, but that's not actually a programming language. So important theoretical programming languages, Turing machines, lambda calculus, and recursive partial functions. These are the ideas that programming arose out of, and I won't explain them. I'm just listing them. So finally, I have a thing on Turing completeness. Um, so Turing completeness was this discovery that was made early in the 20th century, which says that, well, it means that there is uh, that all programming languages have the same power in a certain sense. So when people came up with these things back in the day, uh, people eventually proved that they all uh, could could compute the same functions. So none of them, these are very different formulations of programming, but none of them can do anything that the other ones can't do. So there's a, a set of functions that's called the computable functions, which is what you can implement in any Turing complete programming language. And it doesn't take very much to get to Turing completeness. And once you are at Turing completeness, you can't go past it, because you're at the limits of what is possible with a machine that you can imagine, that follows simple steps, and you can define functions that cannot be done in sequences of simple steps. They're beyond our limits. So the key to understanding Turing completeness is the idea that a function or a whole computer can be represented as data. So you can have a computer function that takes a representation of a computer, and it takes representation of input to the computer, and you can write it to emulate what that computer would do, and to give the output of the computer. And if you can prove that a particular programming language can emulate another one, then you know that you can do everything that second programming language can do in the first language. And you can go the other way around just as easily. So once a programming language is able to emulate other programming languages, um, and those programming languages can emulate it, then you know that they're all equally powerful. So some functions are uncomputable, and uh, the way, well, the simplest one is a function that says whether a uh, a a computer will halt with some given input. So instead of emulating the computer, what this function would do is tell you what the computer is going to do after an infinite number of steps. So you can't do that on a physical computer. And I guess I should have put some kind of proof for it, because it's really not that difficult. Let's see if I can remember anything about it. I don't remember. We can go over it some other time. But um, the Turing completeness is what happens when you are at this limit. So you cannot solve, or you cannot implement this function, but you can do everything up to that. Those are the computable functions, and that's Turing completeness. That's what you get if you can do that. Okay, there's my presentation. I hope that made sense.
Man, that was amazing. Sorry, I know I feel like I just left you out by yourself there sometimes, but you were really on a roll, man. I didn't want to interrupt. That was incredible, man. We really appreciate that. I think there's a ton of super good information in there um, for
Okay,
all the
well,
budding programmers.
if you actually try to program, if you just go over my notes, you'll find that it's all really good advice, and it'll
Um,
help you out a lot. And we didn't even have to do any programming. So
I,
you have to do the ABCs on your own, but once I gave you high level ideas that are gonna help you uh, go farther with programming once you get the basics out of the way.
Daniel, I'm going to call a quick audible, man. It would be, if there's any way that you can do it, I'd love to have a text file of this that I can put on our website, so that people can actually just download this without having to go through this video, and just your write up here. If you want
Sure,
to,
yeah. I'll just copy this into a markdown document or something.
that would be amazing. Yeah, I think a lot of people would just love to have just this text document. Um, and also for anybody that's still in the chat, please share this. I mean, this is a gold mine here. And for all 30 some of you that hung out with us the whole time, thank you so much. Please like, share, subscribe, do all the goods. A little personal plug for a second. But seriously, this is a gold mine of information, and I think it really needs to be spread out. So please share this video, post it on your Twitters, whatever you got to do. This is really valuable stuff, I think.
Okay, well, key takeaway is this is the main thing that I wanted to communicate, because I want people, once you actually try it, you'll find that you can do it. And a lot of people uh, that I've seen believe that they can't program 1 minute, but when they actually just give it a try, they find that it's a lot of fun.
Yeah, definitely. I know I'm going to give it a shot. I'm going to be programming some little stick figure fights or something. Anything
Okay,
I
well,
can
yeah,
at
good
this
luck.
point. Yeah, thanks. I'm going to need it for sure. But I'll definitely be referring to this. I'll say that. Well, you got any final thoughts? Anything you want to get off your chest before we wrap this thing up?
Um, no, we got through everything. Are there any more questions? I can keep taking questions as
Yeah.
long as you want, if there are more.
I think it's really just turned into more of a discussion and less about the questions right now. I'm kind of digging through and seeing if there's anything else. Inside Out wants to build. Give him a shout. He's trying to build something. Um, Let's see. A lot of people. Trisha One Love says she didn't expect to even be interested in this, let alone feel like I'm following and understanding. So that's really nice. And I can relate to that too, as never having programmed a damn thing. I was able to keep up, so I think you did a really great job of explaining that in layman's terms. Um, let's see here. Um, yeah, not so much. I think you pretty much covered it all so well that nobody has any questions. It's sort of the vibe I'm getting. Is Boost on Java? How about that?
Um, well, Attila is working on a JavaScript library. I don't think we have anything with Java, but um, if you have a Bitcoin library, it won't be that easy, or it won't be that difficult to do Boost. It's just an output script, and you can probably just copy and paste it from something that already exists. So it's in my GigaMonkey library, so you can get it from there, or from the white paper, or from Attila's JavaScript version.
Very nice. Yeah, Dookie Love just brought up something good too. We are going to be making a channel in our Discord group that is dedicated to developers and programmers and that kind of chat. So be on the lookout for that. I've got to get with a certain couple of people that I want to um, kind of entrust moderation to for that. So I still got a couple little kinks to work out for that. Shouldn't take us too long, but be on the lookout for that. If you want more information about that, please follow us on Twitch at 7963. While you're at it, go ahead and give Daniel a follow too at 24. He's got a way cooler number than we do. Um, but yeah, we will be. I'll be keeping everybody posted on the status of that Discord group. And also, we already have quite a really cool community going in our Discord. Um, lots of lots of good people in there, lots of really great conversations. So if you want to be a part of that, get in contact with us. There's a million ways to do it, and we will hook you up with that link. Um, says here's a question: are you looking for particular skills in programming?
Well, I mean, uh, I would like anyone who is interested in helping me with my library. Um, there's a lot of program or protocols that I would like to put into it, and I would like to make it into a wallet eventually. So if you want to learn some C++, you can talk to me about that. And there's, I mean, like really, you're better off figuring out something for you to do, because there's just a lot of potential projects, and like many things that might potentially earn a lot of bitcoins, and that's kind of uh, like that's kind of good for everybody if you're trying to earn bitcoins, because, excuse me, in order to make the network sustainable, there needs to be commerce.
Okay, that's a good answer. I like that. Um, and how's Matterpool doing? Any comment on Matterpool?
Doing well. Slow going. Um, well, if there was somebody who was really good at JavaScript, I'd really like to talk to that person, because I think that we need some more help there. Um, but um, we're just trying to build services as fast as possible, and everything. I mean, we're just trying to replace all of the hubs in the internet with emulations on Bitcoin.
Okay, cool. Thank you, Trisha, for dropping the link. if you're in the live chat right now, there is a Discord link to our group. Like I said, we are going to be doing a developers channel. We have a big old meme bank channel. If you are more about just coming in and dropping funnies, there's all kinds of great conversation going on all the time in there. So please join up. This is our kind of our main hub for communicating all things in the box. Um, so yeah, thanks Trisha again. Um, let's see what else we got. Has Matterpool successfully mined its first block?
Oh no, not yet. We're still getting the mining pool functioning correctly. So we're kind of we've been growing organically, but we haven't really done anything to try to get a lot of hash power yet. But anybody who connects with us uh, gets the the subsidy and the the mining fees for now. So that's
Cool.
nice.
Yeah, definitely. That's awesome. I heard I believe that it was Price is Wrong, if I'm not mistaken, had mentioned tapping into Matterpool and said that it went quite well for him.
Okay, great. Glad to hear it.
Um, so yeah, it's good. I'm sorry, I'm just browsing here looking for anything else. Um, do you need miners?
Um, well, sure. Well, I mean, we're happy to buy hash power from anybody, but
Sure.
right now we can't afford to grow too much. There's still some work we need to do before we're ready to get really big. But um, we will certainly happily accept any any miners that connect to us uh, up to a certain point, and I'll let you know if we start reaching that point. But you know, right now everything is fine.
Cool. Good deal. Good deal. Well, you know what, Daniel? I think I'm going to go ahead and try to wrap this up for us here. Again, thank you so much for coming on and doing this, man. This has been excellent. I know that I'm really appreciative, and it seems like everybody in the chat has just been eating this up the entire time, man. So many great comments. So much love for you and what you're doing. Um, so again, man, thank you so much.
Okay, well, thanks a lot. I mean, and I'll certainly be around in that programming channel you mentioned, to help with any specific problems people have. But really, like once you get going, you can find the answer to anything on the internet. Like every programming question has been answered somewhere. I should have mentioned this, but like there's Stack Overflow, and then many other resources. There's tutorials for everything. Like the only thing stopping you from learning to program is yourself.
Wow, nice. Absolutely. Yeah, and I'm sure, and like he said too, you know, he'll be hanging out in the Discord channel, and there's lots of really super intelligent, awesome people in there that'll be able to answer any questions you may have along your programming journey. Um, so, uh, thanks everybody. It's been a lot of fun, and Daniel, we will see you next time, man.
Okay, thanks, Animal. I'll see you around.
All right, take care, man.